Hello and good morning, CTS266, Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CCNP Switch course, and this morning's video tutorial is going to be a video tutorial on Discovery Activity number 9 from the Cisco Learning Labs curriculum that we're currently using, which is going to be configuring multiple spanning tree. And so to start our conversation off with multiple spanning tree, you can see the topology we're going to be working with. But let's really quickly review the different versions of spanning tree here that we've talked about so far. So if you remember, we started out with 802.1d. Now this is the IEEE standard of spanning tree. And as such, it supported a single spanning tree instance for all VLANs. So one spanning tree protocol instance for all VLANs. Now, when this came out originally in 1998, what was going on at that time was that Cisco was also working on some different technologies, and Cisco said one spanning tree instance for all VLANs doesn't provide the opportunity to do any sort of load balancing or layer 2 traffic engineering. And so Cisco said, well, we're going to go ahead and we've got this technology called per VLAN spanning tree or per VLAN spanning tree plus. Now, you'll remember from our lecture that PVST was specifically related to Cisco's proprietary trunking encapsulation, ISL. And PVST plus was when you were using 802.1q. And again, this was all based on the original 802.1d IEEE standard. Because with per VLAN, instead of having one spanning tree instance, and we'll put down here for all VLANs, Cisco kind of went to the other end of the spectrum and said, no, we want to have one spanning tree protocol instance per VLAN. So in other words, up here with the IEEE, if I would have created 500 VLANs, I would have one instance of the spanning tree protocol. So all 500 VLANs would follow that same topology. Cisco said, no, we think it's better. If you create 500 VLANs, you're going to be creating 500 instances of the spanning tree protocol, because then you can manipulate or engineer each of the individual instances, which correlates to a VLAN. So, and then we're abundantly aware of the issues with the legacy spanning tree protocol from a convergence perspective. So then we had the rapid spanning tree protocol, which was 802.1w. And Cisco said, and again, this is the IEEE standard here, and the IEEE standard still followed that same train of thought with rapid spanning tree protocol that said you are going to have one rapid spanning tree protocol instance, and I'll just say INST, for all VLANs. So again, if I had 500 VLANs with the RSTP 802.1w standard, if I had 500 VLANs, I had one RSTP instance for all of those VLANs. Again, no way for me to manipulate or engineer which topology these 500 VLANs would follow on an individual basis. They would all follow whatever the RSTP topology worked out to be. So then you fast forward to Cisco, who said, well, no, we still disagree. We think it's a better idea to do rapid per VLAN spanning tree, which correlated to ISL. And remember, we talked, you actually see this in our text, where you will also see this represented as per VLAN rapid spanning tree protocol. And it still for ISL. It's simply just a movement of the R. So the R just moves from here to here. And it's interesting that you see this all over the place, where you'll see per VLAN rapid spanning tree, and then you'll see rapid per VLAN spanning tree. The key thing to remember is that these are the same thing. And so then it also holds true that rapid per VLAN spanning tree plus, which was dependent upon that 802.1q tag, right, also gets represented as per VLAN rapid spanning tree plus. And again, those are the same thing, and both of these are the Cisco proprietary. Pen's not drawn too well this morning. And same thing here, right? These are Cisco proprietary. All right. So again, Cisco said if we've got 500 VLANs, I'm going to have 500 instances of spanning tree. There is going to be one instance of spanning tree per VLAN. And so you can see it's like from one extreme to the other. And so now that brings us to our conversation about multiple spanning tree, or multiple spanning tree protocol, MSTP, which is what we're focused on this week, where when we talk about multiple spanning tree, we're talking about 802.1s, as in Sam. And so what multiple spanning tree is all about, and this is an IEEE standard, it was initially spearheaded and Cisco worked on it internally before its standardization. But what this means is you're going to have one, and actually I probably shouldn't say, you're going to have one multiple spanning tree instance per a number of VLANs. And so what does this mean? Well, this is sort of the happy medium here. So if you look at the standards said it was one spanning tree instance, right, for all VLANs. So it was all or nothing. Every VLAN followed the same topology, whatever that topology worked out to. And then you had Cisco that said, no, 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 we want to have a spanning tree protocol instance for every single VLAN that gets created, so that you can manipulate all 500 VLANs by their own mutually exclusive spanning tree protocol instance. So MST, multiple spanning tree, is, again, it's like that happy medium where I can take an arbitrary number of VLANs and say, okay, for MST spanning tree instance 1, you're going to be responsible for VLANs 10, 20, and 30. And then I'm going to create another multiple spanning tree instance, MST2, and we're going to say that you're going to be responsible for VLANs 40, 50, and 60. And so you can see right away that it's not an all or nothing type proposition here. With multiple spanning tree, I create MST instances, and think of the instances as just exactly what it is. It is an instance of multiple spanning tree into which I can assign an arbitrary number, right? It could be one VLAN, I could put 100 VLANs in there, but again, I get the flexibility to choose which VLANs go into which multiple spanning tree instance. And so that's why I like to refer to this as the happy medium, where, again, you as the network engineer, the network administrator, are dictating which VLANs go with which multiple spanning tree instance, and therefore would follow whatever that spanning tree instance topology might be. And so let's take a look at that. If I go back to the main screen here, and this is always one of the first questions that learners will ask, which is, well, why would I want to do multiple spanning tree? So in this environment here, and this would be your access switch here, this would be distribution 1, and this is sort of your classic, and this is why you'll hear me constantly say that design is such an important facet. It's more important than simply plugging things in to establish connectivity. And so there's a lot of thinking and forethought that needs to go into how are we going to lay out our network topology based on the type of technologies that we're going to be using. And so this is your classic access distro configuration where we've got the access layer. You've probably got any number of hosts plugged in down here at the access layer. And then we've got our layer 2, layer 3 boundary up here with the distro layer switches, right? So when we look at this, how many different spanning tree forwarding topologies could we possibly have in this setup? So let's detail them. So if this is the root bridge, so if I were to say that this is my root bridge, B-R-I-D-G-E, right? And I'll change colors here. So this is the designated port. We'll do red for the first one. So if that's the root bridge, those are my designated ports. Because remember, designated port, root bridge has designated ports for the VLANs for which it is the root. So these are going to be designated, right? Which means that this will automatically be distro 2's root port, and this would be the access layer root port. So then we come to this segment right here, and we need to determine who is sending the lower cost BPDU. Well, chances are this guy is going to be the secondary root bridge. So he'll be sending the superior BPDUs onto this segment. So here's your designated port, and I'll draw this right here. There's the designated port, and that would be the blocking port. And so red will be spanning tree topology forwarding, or spanning tree forwarding topology number 1. So then let's change colors. So let's say that this is the root bridge, that distribution 2 is my root bridge. So if this is the root bridge, that would be a designated port. This would be a designated port. This would be a root port for the access layer switch. This would be the root port for distribution 1, and in this case he would be the secondary root bridge. So this would be a designated port here, and then that is the blocking port. And so blue is going to be spanning tree forwarding topology number 2. And again, because given that one of these 3 switches has to be the root bridge, that is going to drive how the other switches perceive this layer 2 topology. So let's go to the last possible, I guess we'll do black. We'll go to the last possible topology, which is, for whatever reason, the access layer switch became the root bridge. And obviously this is probably the most inconceivable of the 3, right? Is that the access layer is the root bridge. But if it was, this would be a designated port. This would be a designated port, because again, he's our root bridge. So here's the root port. Here's the root port. And I'm sorry. Yeah, there's the root port. I was looking at blue there. So designated port, root port, root port. So then it brings us to this segment here. And now it's kind of sort of a crapshoot as to who's going to be sending the superior BPDU onto the link. So we'll say that D1, for whatever reason, is the superior BPDU. There would be my designated port, and that port would be blocking. If D2 was sending it, it would be designated port and blocking over here. But again, you can see that the key is that this link right here between my distribution layer switches, irrespective of whether D1 or D2 is sending the superior BPDU onto this link, one side of that link is going to be blocked. And so that's it. So number 3 is the third spanning tree forwarding topology, the third and only the third possibility in this architecture that we have here, in the configuration that we have here. So now this is what MST is all about, is that if I had 500 VLANs, right? Let's think about this. If I had 500 VLANs, if I'm using, let's say, again, suspend reality here. Remember, Cisco switches do not run CST, Common Spanning Tree. Cisco switches do not run that. But let's just say for a second that this was, we'll suspend reality, this was CST. Well, depending on where my root bridge was at, whether it's the red topology, the blue topology, or the black topology, that's going to dictate with CST, all 500 VLANs are going to go the same route, right? They're going to forward in the same direction. So if it was the red topology, and we'll say we're here at the access layer, all 500 VLANs are going to go that way. If we're in the blue topology, all 500 VLANs would forward that direction, coming off, assuming that this switch had, 500 VLANs on it. And 3 would be the black topology, where it would forward out either of the links, because both of these links are designated ports. Now that's common spanning tree. If we looked at the way Cisco does it on the per VLAN, I could say VLANs 1 to 250 would be would forward to the distribution layer 1, and this is all this per VLAN. So you can see I can manipulate it per VLAN, and then say 251 to 500 will come this way. So 251 to 500 are going to go that way, and 1 to 250 are going to go this way. So I'm basically splitting, 50% go forward one direction and 50% forward the other direction. But again, the drawback to this is that I'm running 500 individual instances of spanning tree, one per VLAN. Now, is that really necessary in the scenario that we're looking at right here? Because there are only 3 total possibilities, of which 2 would end up being implemented. And I say that because this here, with the root bridge down here, you typically, and you would never see this. You should never see this in a production enterprise environment with an access layer switch serving as the root bridge. And one of the reasons for that is what you're looking at right here, which is that link between these distro layer switches is going to be blocking. And so if I were to redraw what we've got here with the red topology, and I'm going to pull out the block links, and this is always something to do when you're trying to work out issues, or I should say manually work out what the spanning tree topology is going to look like. So let's draw the red topology without the block link. And so here is what the red topology looks like. You can see that the block link, which is the link between the access and distro 2, that link was blocking. If we draw it out again in the blue, what do we have? We've got distro 1, we've got distro 2, and we've got the access layer switch. In our blue topology, it looks like that. And again, we're missing that blocking link. I'm not drawing it in there intentionally because it is blocking, and you can see we're avoiding the loop. And then finally, if we look at distro 1 and distro 2, from the third possible topology, it's going to look like this, right? Where there is no communication between these distro layer switches. And this is, again, from a design perspective, this should never be seen where the distro layer switches do not have connectivity between each other, or that link is being blocked. And so what multiple spanning tree allows us to do is we create an individual multiple spanning tree instance into which we can place an arbitrary number of VLANs. Because again, we would only need, in a properly designed network, even if I wanted to use the access layer as a root bridge in some scenario, I would only need a maximum of 3 spanning tree instances running here, right? And I can't get that with common spanning tree, and I certainly can't get that with per VLAN spanning tree or rapid per VLAN spanning tree. I can't get that with these two here, right? Here we get one instance of spanning tree for everybody. Here we get a spanning tree instance per VLAN. And so then again, we arrive at this happy medium called multiple spanning tree, where I can create MST instance 1, which says that this is my root bridge, and I'll create MST instance 2 that says that this is my root bridge. Because again, these are the two topologies that you're trying to get anyway when you're working with per VLAN spanning tree or rapid per VLAN spanning tree. Is that the distro is going to be the distro 1 will be the root bridge for half of my VLANs, and distro 2 would be the root bridge for the other half of the VLANs. But again, the overhead that gets created when you get to a large number of VLANs is the major concern. Do I really need to have 500 spanning tree instances spun up in order to simply load balance them across these two distro switches? And that is the real value add of multiple spanning tree. The other value add is that some switches don't support a high number of spanning tree protocol instances. I believe the 3750, I want to say it's 128. So once you get above 128 VLANs, when we're talking about per VLAN spanning tree, once you're above 128, there is not an instance of spanning tree created for those additional VLANs. So then you've got VLANs above 128 that are running in your topology with no corresponding spanning tree instance. On some lower end gear, I believe the 2950, I think it's 64 instances of spanning tree is the max. So once you're outside that, then you're creating VLANs that have no associated spanning tree topology. All right, so hopefully this has kind of really coalesced and pulled everything that we've talked about over the last 3 weeks together. Again, we started out with spanning tree protocol 802.1d per VLAN spanning tree plus, right? But remember, the standards, it's a single instance of spanning tree for every single VLAN. And then we talked about Cisco's implementation where it was per VLAN. And now we're talking about multiple spanning tree, which is I can have multiple instances. In this case, we really only need 2 in our topology here in order to facilitate the load balancing. Now, we'll talk about this more as we go on, but remember, underneath multiple spanning tree, right, it is the rapid spanning tree protocol that is running and doing all the calculations that are required for spanning tree to converge. It is RSTP 802.1W that is being used. And if you think about it, it makes sense, right? Because remember, the standard RSTP is one instance for all VLANs. So I create this MST instance for all the VLANs I want to have in this MST instance that is powered under the covers by RSTP. Now, the reason it's running RSTP and not rapid per VLAN spanning tree, why do you think? Exactly, because rapid per VLAN spanning tree is not needed. I don't need an individual spanning tree instance per or for every single individual VLAN. So we can use RSTP, right, behind the scenes, behind the curtain here, for MST. And that is why we're able to stick in an arbitrary number of VLANs. All right, let's clear the screen here. If you're going to screenshot this, now is the time to do it. And I'm going to squeegee this off, and we're going to jump into this activity. Again, these Learning Labs activities are absolutely fantastic. So let's go ahead and jump on to switch 1 here. We're going to go from user exec into privilege exec. And here's what we're talking about. Let's actually pull all 3 switches up. So let's go ahead. Let's implement multiple spanning tree in the topology that we're presented with. So let's go ahead and say show spanning tree summary, and let's see what things look like right now. And we can clearly see here that we are running, and black is probably not the best color right there. You can see that we are running, and where did it go? Right here. Switch is in per VLAN spanning tree mode. Again, I'm creating a spanning tree instance for each and every individual VLAN has its own spanning tree instance. And then the platform, whatever platform I'm on, has to track all of that information. So they want us to do that, to take a look real quickly. And whoops, almost dropped my pen there. To take a look real quickly. And so then if we were to say show spanning tree, what you're going to see is there's the VLAN 1 spanning tree information. It's got to track all that information. Here's the spanning tree instance for VLAN 2, VLAN 3, VLAN 4, right? So you can see kind of the challenge here is that we're, again, having to keep track of CPU memory-wise all of these individual spanning tree instances. So we're going to go ahead and we're going to configure on switch 1, we're going to go ahead and configure spanning tree. We're going to configure multiple spanning tree. Now here's how you want to start off. What you don't want to do, and especially in a live environment, would be to jump on a switch and say spanning tree mode MST. And you can see there's only 3 possibilities here. It's either per VLAN spanning tree, rapid per VLAN spanning tree, or multiple spanning tree. So this right here, you would not want to do this because we haven't created the multiple spanning tree configuration. We haven't created a name. And again, there's going to be 3 things that are of utmost or critical importance when we're talking about multiple spanning tree and being intra-region to make sure that the switches are in the same multiple spanning tree region. And 3 things need to match: the name of the multiple spanning tree region, the revision number, and then what I like to call the VLAN to instance mapping, which is like it's this 4,096 element table, right? 1 element per every possible VLAN, 0 to 4095. And so it's this VLAN to instance mapping, and all 3 of these things are communicated in what's called a hash, and we're going to see what those hashes look like here. But it's all communicated in a hash to the neighbors. And if the hashes between neighbors don't match, then it goes into inter-region functionality, right? Or inter-region behavior. So you don't start off by simply saying spanning tree mode MST. So how do we start off? Well, we're going to configure all 3 switches to be part of the same MST region. So we're going to say spanning tree MST and take a look at some of the options we've got here. So here's where we're going to go into configuration mode. You could manipulate the forward time, the hello time, the max age. So again, all of those values that we're familiar with from legacy 802.1d and rapid spanning tree 802.1w, those are also options here. And this is one of the differences with multiple spanning tree, is that the command syntax changes a little bit where we're putting MST in there. We're not putting spanning tree VLAN 5. We're putting MST. So let's get into configuration mode here. So I type in spanning tree MST configuration. Let me say show current, right? And show current is a great command because it shows you what's currently configured. And this leads to a very important part of the conversation, which is, okay, I see that I have no name, my revision number is 0, and here is your VLAN to instance mapping, right? And it's basically instance 0 is mapped to all possible VLANs. Remember that 0, I shouldn't say through 0 and 4095, that those are reserved, so those would never show up here. So we've got this MSTI, multiple spanning tree instance 0. Now, this is also called the internal spanning tree, IST. So MSTI is referred to as the internal spanning tree. And this spanning tree instance, or this multiple spanning tree instance, always exists, and it always maps all the VLANs that are not mapped to another multiple spanning tree instance. So this is kind of like, think of it as like the catch-all. So if my VLAN, like VLAN 10, doesn't get assigned to another instance other than 0, then it would show up as being mapped to instance 0. So this is kind of like, trying to think of a good analogy. So this is kind of like the bucket from which we're going to pick out all of our VLANs. And as we pick them out one at a time and assign them to one of our 2 created spanning tree, multiple spanning tree instances, they'll disappear from up here and they'll show up as being related to our multiple spanning tree instance that we're going to create. But all the VLANs will be here to start, and then it will show you which VLANs are left over and that haven't been mapped out to other MSTI, multiple spanning tree instances. And again, MSTI0 is the internal spanning tree, okay? All right, so let's go ahead and squeegee this off here. So show current shows me what I currently have. I could also say show pending. And show pending is going to show me any changes that I've made during this MST configuration session that haven't been applied. All right, so let's go ahead and set our name. So we're going to say name, CCMP, and let's set our revision number. We'll start off with 10, right? The activity shows 1, but we'll start off with 10. So that's it for switch 1. Now let's come over to switch 2. And we'll go from user exec into, into privilege exec, into global config, and we're going to say spanning tree MST configuration. Then we're going to say name CCMP, and we're going to say revision 10. And then finally we'll come to switch 3. Now the key thing to remember here while we're doing this is that we haven't turned multiple spanning tree on yet. We're simply setting the configuration up so that all of these parameters match that we need to have match. Again, the multiple spanning tree name, revision number, and VLAN to spanning tree, VLAN to instance mapping. All right, so that is our base config, and this is what you want to do first. Now, if you're following along, we're on step 3. So let's go back to switch 1. We'll just do each switch in turn here. So here is the whole, this is where the rubber hits the road in terms of this name, multiple spanning tree. Because this is where I'm going to create the 2 instances I need. Remember, there are only 2 spanning tree topologies here that are of interest to me. And yellow is not going to be a good way to demonstrate that. So there's only 2 that are of interest. Either this is the root bridge, and we'll say MSTI, multiple spanning tree instance 1, or this guy over here is going to be my root bridge, and he would be MST, multiple spanning tree instance number 2, right? So, and I'm going to map the VLANs that I want to use this switch as the primary for to MSTI2, and I'm going to map the VLANs I want to use that guy for to be part of MSTI, multiple spanning tree instance 1. And so this is how we do the mappings. So we created the spanning tree config, we gave it a name, gave it a revision number. Now the third component, which is critical that needs to match across the board, is going to be instance. And if I do a question mark here, you can see that the instance ID could be anywhere from 0 to 4094. So we'll just stick with 1 as they show. And which VLANs do I want to map to instance 1? So we're going to say VLAN 2 and VLAN 3. And then I'm going to come back, and here's where I split my VLANs up, right? This is my layer 2 traffic engineering. We're going to say in instance 2, we're going to do VLANs 4 and 5. So again, what have I just done here? I've basically done my layer 2 traffic engineering. Again, you can think of it as like, oh, so he's doing it per VLAN. I am, but think of it more of per instance, per spanning tree instance. So instead of a single instance for all of my VLANs, or an instance per every single individual VLAN, I've created 2 multiple spanning tree protocol instances that are going to support an arbitrary number of VLANs. Again, I could put 1 in here, I put 2, like I just did here, we could do 2, or I could put 200 per I could put 200 in instance 1, I could put 100 in instance 2. Again, you've got the full flexibility to be able to make the changes that you want based on your topology and your desire. So we've got this VLAN to instance mapping. Let's now go back and say show pending. So that's what's pending, right? And you can see that we've got these 2 additional instances now. So I've got instance 1 and instance 2. And those are the instances that I just created here and here, right? And you can see what VLANs are mapped to instance 1, 2, and 3. Which VLANs are mapped to instance 2, 4, and 5. And take a look at the change here. MST0, the IST, the internal spanning tree instance, MSTI0, has everybody else that is not mapped to a user-configured multiple spanning tree instance. So he's got 1, comma, and then 2, 3, 4, and 5 are mapped out here. So 1, comma, 6 through 4094. And as you get into larger scenarios and larger environments, you'll see that this MSTI instance 0 can get pretty long depending on which VLANs are being picked off for use in other MSTI instances. And so that's pretty much it. It's very, very straightforward. Now, what we need to remember is that this needs to match across all the switches. So again, we said show pending. If I say show current, take a look. The current still says that nothing's configured, because in order for this to take effect, just like when we were doing some VLAN work, when I'd have to exit out of the VLAN configuration mode in order for those VLANs to show up, it's the same thing here. I have to type end. Now again, we have still not changed the spanning tree mode. So if I were to say show spanning tree, we are still 802.1d legacy IEEE compatible spanning tree, or in Cisco's terms, PVST or PVST plus, depending on the trunking end cap. But I'm out. So now if I were to go back into, and actually let's go ahead and go into global config. Whoops. If I were to say spanning tree MST configuration now, and now when I say show current, take a look. So now the current MST configuration, right, shows what we just did. Name CCMP. Now, important about that revision number. That does not auto-magically increment for you. Okay? So it's up to the administrator when you go in to change that revision number. And we'll talk about the implications of that when you're making changes to multiple spanning tree in production environments. And the things that you need to take into consideration before you go in and start making changes and changing the settings, one of these 3 settings that are supposed to match across all the switches in the same region. Okay, so if I were to say show pending, right? So the pending matches the current because, again, when I type end, I haven't changed anything, nothing's going to change. All right, so that's switch 1. Let's work our way over to switch 2 now. So we're in this spanning tree configuration mode. Let's say instance 1, and now this has to match. These need to match throughout the environment, or else we're gonna see inter-region behavior. So instance 1, VLAN 2 and 3. Instance 2 was VLAN 4 and 5. And then we'll say end. And let's come over to switch 3. And remember, we have not turned on multiple spanning tree yet. We're just setting the foundation, right? We're laying the foundation here so that when we do turn it on, it works as we expect. VLAN 4 and 5 and end. All right. So right now, we've got all 3 switches properly configured. And so the next thing we need to do, because if you think about it, we haven't said, if I say show span, who's the root bridge, right? We haven't done that final step, which is where we say based off our diagram here, we need to say who is the root bridge, right? So right now, the root bridge is whatever it worked out to by default here. But this is where we now need to tie our MST multiple spanning tree instance 1 to switch 1. And let me make sure that's what we're doing. Yeah, that is what we're doing. As the root bridge. And then we're going to tie multiple spanning tree instance 2 to switch 2 as the root bridge. So in other words, VLANs 4 and 5 will forward that way from our access layer, 4 and 5, and then VLANs 1 and 2, or I'm sorry, not 1 and 2, 2 and 3. Yeah, 2 and 3. VLANs 2 and 3 will forward that way in our topology. And again, this is what they're going to see as the root bridge, because for the, we'll say the red VLANs, MSTI1, VLANs 2 and 3, that link will be blocked. For VLANs 4 and 5, that link is going to be blocked. And so this is, again, the real power of multiple spanning tree, is that we're able to pick off an arbitrary number. It doesn't have to be 2. It could be 200, right? It could be 2,000. But again, it's an arbitrary number. But we only have 1, 2, and then under the covers that MSTI 0, our internal spanning tree instance. So for a grand total of 3 multiple spanning tree protocol instances. So compare that again. If I had 500 VLANs, instead of only needing 3 MSTP instances, I would need 500 either per VLAN spanning tree or rapid per VLAN spanning tree instances that I would need to track and maintain. All right, so let's squeegee the screen off here. And now we're going to go ahead and we're going to set the root bridge per multiple spanning tree instance. So we're back on switch 1. I'm going to say end, and we're going to go into global config, and this is where we say spanning tree. Now remember what we used to do, right? I'll do a question mark here. I used to say spanning tree VLAN, and this is a common mistake when making that transition from PVST, RPVST to MST, is to say spanning tree VLAN 2, 3, and then say, I could say root primary. Now, when you do this, all you're changing here is the either 802.1d or 802.1w spanning tree. This does not change anything for the multiple spanning tree protocol. So what we need to do is we need to say spanning tree, and this was that syntax change I referred to. You need to say spanning tree MST. And this is where I'm going to put in the instance number, right? And you can see the word that they list here. This is where I put the instance, just the instance, or if there's a range of instances I'm working with. But we're just working with this one, right? So MST1, and let me click in there. All right, so spanning tree MST1 root primary. Now remember, we still have not converted these to run MST. This is the foundational work that needs to be done up front, and especially if you're in a production environment, that this should all be done first before we go in and say spanning tree mode MST. Because once you type in spanning tree mode MST, it is going to be expecting that if we wanted all 3 of these switches in the same region, that all of their configuration information is the same. And if that's the first command that you type, then it's not. It's not going to be the same, right? So spanning tree MST1 root primary, and now let's make this the secondary, spanning tree MST2 root secondary. And again, I'm doing the macro. I could have just as easily said spanning tree MST2 priority and then given a priority number here, right? But I'm choosing to use the macro, so root secondary. And now we've made for switch 1, it'll be the primary root bridge for VLANs 2 and 3, because those are mapped to multiple spanning tree instance 1, right? And switch 1 will be the secondary root bridge for multiple spanning tree instance 2, which means the secondary root bridge for VLANs 4 and 5. So now on switch 2, we need to do the exact opposite, right? Because remember, we're trying to say that switch 1 is my root bridge, MST I1 for VLANs 2 and 3, and switch 2 is going to be the primary root bridge for multiple spanning tree instance number 2, in other words, VLANs 4 and 5. So we'll go into global config. We're going to say spanning tree MST, and again, for 1, it's root, but am I primary or secondary over here? Exactly. I'm the secondary root bridge for the VLANs that are mapped to multiple spanning tree instance 1. However, for VLANs mapped to multiple spanning tree instance 2, I am the root primary. All right, so if you're following along, we've just wrapped up step 5. We are now on step 6. And step 6, this is sort of the point of no return. We've got everything configured, right? We've got the name, CCMP, and that's it. You have a 32 character limit in that name, by the way, 32 byte limit. So 32 characters. We've got the configuration revision, which can be a maximum value of 2 bytes, right? 16 bits. So 65,535. And then we have our VLAN to instance mapping. Now remember, those 3 things must match, or we're going to have inter-region communication instead of intra-region communication. And we'll talk a lot more about that in terms of how it refers, or how it rolls back to sort of the common spanning tree behavior, so to speak, when you're doing inter-region communication. And so what we're going to do now is we are going to activate the multiple spanning tree mode, because we've also configured our primary and secondary root bridges. So before we do that, let's say do debug spanning tree events. So this should be pretty good. So let's go ahead and say spanning tree mode MST. And now here's where you were probably thinking, well, why didn't we just type this at the beginning? Again, we talked about that, where you have to have all of these other things sort of already configured, laid out, ready to go. Now we say spanning tree mode MST. And I do this on switch 1, and take a look. And God, I love the debugs. Love the debugs. So what do we get right away? Let's switch over to yellow here. It pops a little better. So what do we see here? Whoops. What do we see there? So we see spanning tree per VLAN spanning tree fail, right? Blocking designated port Ethernet 01, and it's doing the same thing up here for Ethernet 00. So, and those are my connections from switch 1 out to switches 2 and 3. And so the reason that it's failing is because we have multiple spanning tree protocol configured on switch 1, but the other 2 switches are not running multiple spanning tree. So let's take a look at, from a sort of a, not a configuration perspective, but from a, what am I trying to say? A validation perspective, if you will. So do show spanning tree. So take a look now. What is MST instance 0? And notice how it's showing up here. It's showing MST instance 0. If we come down further, here's MST instance 1, and then we'll roll all the way down to MST instance 2. But take a look at what's happening. So you can see that what we're seeing out Ethernet 00 and 01 is a legacy per VLAN spanning tree neighbor. And that's what this means, this bound PVST. So he sees switch 1, sees switch 2 and switch 3 right now as inter-regional. It does not see switch 2 and switch 3 as being a member of the same region as switch 1. And the reason why is because he is listening to the BPDUs that he's receiving, switch 1 is, and he is seeing per VLAN spanning tree BPDUs showing up on these ports. And unfortunately, he's going to push them into a PVST inconsistent state. And what does that result in? Right? It's blocking. And so right now, we've got a broken topology here for, excuse me, multiple spanning tree instance 1 and multiple spanning tree instance 2. And you take a look at this subtle change right here. Our spanning tree protocol is MSTP, right? Multiple spanning tree protocol. You can see that our root values, that we are the root, right, for MST instance 1, okay? And it shows the root priorities there. And then here, you can see it says this bridge is the root for MST instance 2. Now, again, remember we set switch 2 up to be the secondary, so why do you think it's shown as primary for both on switch 1 right now? Exactly, because the links are down, right? We're blocking. We're in an inconsistent state. We haven't established intra-region communication between any of the other switches yet. So let's go ahead and let's make that happen. But I always like to take a look at what happens when it's not correct, right? It's always a good idea. Let's see what happens when things are broke. Let's see what the debugs tell us. Let's see what kind of behavior we're getting from the switches. So now let's transition over to switch 2. And let's go ahead and say the same thing. Do debug spanning tree events. And let's do it. Let's kick it off here. So spanning tree, and you can see we're debugging right now, and it looks like it's receiving root BPDUs on Ethernet 02. And so if I'm on switch 2, Ethernet 02 is right here, right? And so you can see why this is a problem. He's receiving on Ethernet 02 BPDUs saying that, hey, I'm the root bridge. However, there's no communication here. That link is blocking data traffic. So we come over to switch 2 and let's take care of this. So spanning tree mode, and again, throw that question mark in here, MST. And let's see what we get now. We should see some fireworks here. So you can see he's generating a topology change trap for port Ethernet 02. We come over to switch 1. And we see the same thing. We've got a topology change trap. And then that is it. So if I were to now say show spanning tree, or show, let's say, yeah, we'll say show spanning tree. And we'll come down here to MST instance 1 and instance 2. What has disappeared between these guys? Right? You no longer see out Ethernet 02 on switch 2. It doesn't say bound PVST because the other end of Ethernet 02 is that's switch 1. However, we still have this bound PVST, right? So we have a legacy PVST neighbor out Ethernet 01. We know that's the access layer switch, right? Excuse me, show spanning tree summary. Excuse me. So here we go. So instead of seeing 500 spanning tree instances, one for every VLAN we could be using, what are we seeing? We're simply seeing the 3 spanning tree instances that we are interested in, right? MST0, which is the internal spanning tree instance. We've got MST1 that we created and MST2. And then it shows us, here are my 2 VLANs that I have forwarding in each. And here are the 2 VLANs, how many VLANs are active in this spanning tree protocol, and it's 2. So again, we come up here, the switch is in MST mode IEEE standard. Remember, when we were doing per VLAN spanning tree and rapid per VLAN spanning tree, we would see PVST or rapid PVST up here. Now, on switch 2, take a look. We are the root bridge for multiple spanning tree instance 2. So if I scroll back up a little bit, you can see here, MST2, I am the root bridge. But for MST instance 1, he is not the root bridge. It's switch 1. Let's see if switch 1's output changed at all. So do show span. So it does. So now that the root bridges are both online, and this is also an important point, if you're doing a migration in a production environment, this is definitely something that you want to make sure that you do from the inside out. In other words, start at your root bridges, like we did right here, and then work your way outward. Because MST is backwards compatible with per VLAN spanning tree and with rapid per VLAN spanning tree. And we'll talk about that. It reverts to per VLAN spanning tree mode for non-intra-region speakers, right? Like you see here, this PVST mode, it's bound to a PVST neighbor, but it will function. So start from the inside. Start at your root bridges, work your way outward to the, you look at the root bridges as the spine and look at the access layer switches as your leaves, right? So go from in to out. And the reason is you wouldn't do this out on an access layer switch somewhere that's not the root bridge, because then you're going to run into all kinds of issues like we just saw. All right, so we've got that taken care of. We can see the limited number of spanning tree instances that we need. Let's do, I believe a switch 3 is still running. Show span. Yes, so we have one last switch here. So spanning tree mode MST. And let's come over here to switch 1. Do we see anything from the debugs here? Switch 2, anything from the debugs? All right, we didn't see any debug information. So let's go ahead and say show spanning tree summary. And switches in MST mode, IEEE standard, right? And we've got our information here about, and it looks like it might still be in the show span. Let's take a look here. All right, there we go. And so there's the topology. So remember, switch 3, and let me double check, that's our access layer switch, right. So switch 3 is the access layer switch. Here are our two multiple spanning tree. I'm trying to get that last MSTI in the frame up there at the top, so we'll leave it right there. So here are the two multiple spanning tree instances, right? MSTI1 and MSTI2. So we know that this is VLANs 4. Oops, that's a terrible 5 there. Let's just get rid of that. This is VLANs. My pad is filling that in. So 4 and 5. And this is VLANs 2 and 3. So what does our topology look like from switch 3's perspective for multiple spanning tree instance 1? Well, we've got our 3 switches. There's switch 1, switch 2, and switch 3. So for VLANs 2 and 3, the root port is Ethernet 03. The alternate or blocking port, remember we're running rapid spanning tree protocol is doing the work under the covers here. But again, it's blocking. And so this is what the topology looks like from switch 3's perspective for VLANs 2 and 3 in MSTI 1. And now let's take a look down here. We got switch distro 1, we've got distro 2, and this is VLANs 4 and 5, and then we have our access layer switch. So from switch 3's perspective, the root port for this MSTI2 is the root port is Ethernet 02, which goes that way. And his alternate port, which is blocking, right, it's blocking the loop, here is his alternate port. Because again, this is my root bridge, this is my secondary root bridge. Here, this is my root bridge, this is my secondary root bridge. All right, so that's pretty much it. I mean, that's really all there is to multiple spanning tree. It's just looking at things from the perspective of, instead of having a spanning tree instance for every single possible VLAN, that I'm just going to create an instance for an arbitrary number of VLANs based on my topology and how it's laid out. All right, So let's go ahead now. Let's talk about what gets exchanged, that BPDU that's getting exchanged. In order to see that, let me click here. So we're going to say show spanning tree, MST configuration digest. Now, here is the information that needs to match. And this is the hashing information that is being exchanged. Now, we see two digests here, right? And I'll talk about this in a second. So here is the digest we're interested in, and that needs to match, or else the spanning tree neighbor will not be considered intra-region, in the same region, because the three things that need to match are the name, the revision number, and the VLAN to instance mapping, and you see instances configured 3, that is all communicated in this digest. Now, pre-standard digest. Why and what is pre-standard digest? Well, remember, we said that Cisco was working on a version of multiple spanning tree prior to the standardization, and it was MISTP, Multiple Instance Spanning Tree Protocol. And this is what they were working on internally. And so that digest there is for any older legacy switches that are running sort of the quote-unquote Cisco proprietary version of, or I should say Cisco, I don't want to say proprietary, let me take that back. Cisco pre-standard version of multiple spanning tree, which I guess you could consider proprietary, but again, pre-standard. And so that's why it's annotated here that if I've got a legacy neighbor who does not speak IEEE Multiple Spanning Tree Protocol, that this pre-standard digest would be exchanged, so that even a pre-standard Cisco switch would be able to participate in the multiple spanning tree topology. Okay, so let's go ahead and clear that off. And again, if they didn't match, you would know. And if we'll come over here, we'll say do show spanning tree MST config digest. And you can see Baker, Charlie, Baker 2 at the end of the digest. So we're good there. Do show span. But we know that we would see something indicating that something is wrong here, right? We would definitely see something indicating that something could be wrong. So let's go ahead now. If I drop out here, and on switch 3, it wants us to do show spanning tree MST1. And so again, remember, this is just multiple spanning tree instance 1. If I wanted to see 2 and what 2 looked like, I would enter it in like that. And so you can see the bridge, that's the local bridge. Here's the root bridge address and information, right, on switch 3. And you notice that switch 3 sees different root bridges because, again, the root bridge for MST I1 is switch 1 and MST I2 is switch 2. We're going to get a little bit more into the cost and how the cost value changed later, but you should also have kind of seen this and said, hey, wait a minute, why am I seeing a cost here of $2 million? What does that mean? I thought fast Ethernet was 19 and regular Ethernet was 100. Why does it say 2 million here? And so again, the cost values are going to change as well. All right, so the final thing that we're going to do is let's change something here in the spanning tree configuration. Let's break this. So spanning tree MST configuration, and let me say show current. So that's what it currently looks like. So again, I've been telling you these things have to match, or else the switch would be treated as an outsider. He wouldn't be in the multiple spanning tree circle of trust, right? So let's go ahead and do this. Let's, what are we going to change? Yeah, let's change the revision number. So let's change the revision number to 99, right? So when I say show current, everything still matches and we're still good. When I say show pending, the revision number shows 99. So what happens when I say end? Because again, the revision number is now different. So what impact is changing, whoops, let's click in here, changing the revision number going to have on switch 3 because that information obviously no longer matches. So let's say show spanning tree MST1 and take a look. I immediately revert back. Now remember, we're on switch 3 here, so take a look at what is happening here. I immediately revert back to legacy spanning tree functionality where I'm showing that I'm bound to an RSTP neighbor, that I am not in the same region as these neighbors. And if I were to do show, sorry about that, if I were to do show MST2, we're going to see much of the same, right? To where we're bound to a rapid spanning tree protocol neighbor. But again, my address is listed here as this switch is the root bridge for MST in multiple spanning tree instance 1 and 2. And you can see the VLANs that are mapped, right? But I'm not the root bridge. We know that I'm not the root bridge because we changed it to the distribution layer 1 and 2. And so this is your first introduction into inter-region spanning tree. And so you'll also notice we've got this new role down here, master, right? We still have our alternate, but we've got this new role master. We get into that a little bit more. So we're going to go ahead and wrap up Discovery Activity 9. Again, kind of another tour de force here, supplement on the multiple spanning tree protocol. All right, well, hopefully this has really pulled together everything that we've talked about over the last 3 weeks with respect to spanning tree and clarified the different versions of spanning tree, the different Cisco proprietary versions or Cisco implementations of the standards, and now we're into multiple spanning tree this week. All right, thanks for watching. I will see you guys on Monday night.